Now that we have already assembled all the hardware components of the quadcopter, we just need to calibrate it in order to make it fly properly. So all that we'll need for that instance is the quadcopter, then the universal serial bus wire, just to communicate between the computer and the drone, and finally the radio transmitter, because it is a component that also needs to be calibrated. So now what we need is to download the required software, that is the APM planner, that can be downloaded from Arduino. Step, we need to connect the quadcopter with the computer. So we connect it to the USB port in the APM, which is written on the surface, and then the other to the USB port in the computer. So the first thing that we'll see are some lights that are blinking and some that are not. So the green one that is solid means that the APM is receiving voltage. Then a yellow one that is blinking means that the flight controller is connected to the computer and they are transmitting data. Then we have a blinking red light. That means that the quadcopter is not armed. When this light is solid, it will mean that the quadcopter is armed. And finally, the blue one means that the GPS, if it is blinking, that is not receiving data, and if it is solid, it means that the GPS is receiving data. We need to connect the software with the APM. For that instance, we need to set parameters here for our convenience. So first of all, we need to select the port, the communication port for the serial communication. So please make sure that the selected port is the one you are using. And finally, the baud rate needs to be settled to 115200. If not, the communication won't be possible. Now click on connect. You just need to wait some seconds until you see in the main window that the software is receiving the data. So now we see this, that the receiving data from the altitude, the battery, and also from the accelerometers. Here we have in this primary display, we can check that the communication is established properly. So all the movements. Now let's take a look at the main possibilities that the software APM planner offers, and the main windows. So here is the primary flight display that, as we have seen, it displays the movement of the quadcopter and also some parameters. Here we have also a main window that displays the position of the quadcopter in a map. Then in the second window we can define a sequence of waypoints. Just clicking on a point on the map, we can define a sequence of waypoints. This way we can do our quadcopters to fly between these points. We can modify them changing, also set the altitude, different. We have a lot of things to do, but we are not using it because we need to fly indoor. The third window, initial setup, we have different possibilities. We need to install the firmware, which is the codes necessary for the flight controller. We have to set some parameters for example, the X style. Here later we'll perform the calibration. So these are the required parameters that we need to settle before to fly the quadcopter. Then on the configuration tuning, this is useful for tuning the quadcopter, so that is to settle the PID parameters, so to make the drone fly stable. Then on the last window, here we are able to plot some data, some outputs of the quadcopter. Now let's go with the initial setup. First, we need to install the firmware. As we have already installed it, we don't need to do it, but in your case, if it is your first time, you will have here an icon and you will need only to click on it and it will be installed. Now the mandatory setup. We have to select the frame type. As we are using an X style quad rotor, we just need to select this kind of quad rotor. Here the compass, we need to click on enable and click on auto declination. Leave the other parameters as default. And also important, we need to select the roll 180 degrees. Please, we have different options, but for our compass the option is roll 180. Now we need to calibrate the compass motor. So click on compass motor calibration. There is a caution message because the propellers are going to start rotating. So now, first of all, we need to arm the motors. How do we do this? Just moving the throttle to the lower right
System
position.
1 is armed.
So now the motor has started rotating. So we need to, on that window, we need to click on start. There is throttle node 0, sorry.
Link lost to System 1.
Measuring the interferences. We need to go increasing the throttle. Don't raise it too much, just until the 45%. Okay, that's enough. We don't want it to fly, so just click on stop.
Link regained to System 1 after 59 seconds.
And click on OK. We have new value. So then, the accelerometer calibration. This is completely mandatory. You always need to do it for the first time. So just click on calibrate and we'll follow the instructions. So place the vehicle level, so that is, it is on level, so click on OK. Then place vehicle on its left. Try to do it safely. This is our no. This is so. Please remember, white arms are from the front side and red arms are the rear part. So this now is on the left side. Click on continue. Now on its right, continue. Place the vehicle nose down. So nose down. So please make it softly, not to damage any of the propellers, motors. Now, place the vehicle nose up. Click on continue. And finally, place it on its back. And click on continue.
Link regained to System 1 after 11 seconds.
As a result, we have obtained the offsets and the scaling parameters that have been achieved by the ellipsoid calibration method. We need also to calibrate the radio, so that for that instance we need the radio transmitter. We first switch it off, switch it on, and we see that it says that place all switches in their up position and the lower the throttle. So all the sticks in their up position and the throttle in the lower. Now it's working. We can check it if we are receiving data on the window, if it is changing. So okay, it's receiving. We are communicating via the radio, and now click on calibrate. So now we are going to set the maximum values and the minimum values of the throttle, the pitch, the roll. So we just need to perform all the movements, all the degrees of freedom of the transmitter. So throttle, yaw, pitch, and roll.
Channels.
All the channels. And now we have more additional channels, 2 more ones that are controlled by these buttons. So this is channel 5 and this is channel 6. Our transmitter has only 6 channels, so we don't need to perform or to calibrate more channels. So now click on end calibration, and we have collected our maximum and minimum values of each channel. In the next window, the flight modes, we can select different modes. For example, stabilize, acro, altitude hold, auto, loiter. So for beginners, the most useful mode is the stabilize one or the altitude hold. So please select one of these 2 modes. How can we change it? The one in green is the one we are using. So please make sure you don't change this, you don't move channel 5 when you are flying unless you know what you are doing, because you can change the flight mode and the drone won't fly properly. And finally, the fail-safe mode, we are not going to use it because it requires the GPS, and so to fly indoor it's not required. So we have already finished the mandatory setup. We need to calibrate the speed controller. For that purpose, we need the quadcopter, the battery, and the transmitter. The first thing we have to do is to turn on the transmitter. Please look at the warning message. We need to have the throttle down and all the sticks up. Now we start calibrating the speed controller. We need to push the throttle up, then connect the battery. Please notice that a yellow light is blinking between the red and the blue line. That means that the red controller has understood that it's in the calibration process. Then we need to unplug the battery and connect it again. Please make sure that you have heard 3 short beeps. That means that everything is going right. Finally, we need to push the throttle down. And we should have heard 2 short beeps and 1 long beeps. That means that the speed controllers are calibrated. Now we can check that if we up the throttle, the motor are rotating at the same velocity. If not, we should repeat the process.